So good afternoon, everyone. I'm Matt Seddon, Solution Sales Specialist here at Power on Platforms, and this is the first of our webinars or webcasts that we're going to be doing every week from now on, continuing on these themes to really bring what is the latest information coming through from Microsoft. Well, we're finding that a lot of customers are really wanting that information, that knowledge in quite a digestible format, which seems to be this seems to be one of the various methods that we're currently doing this from. This one is the end user compute, so why migrate to Windows 10? And it's going to be Vishal, who is the consultant that's going to be taking this session today. We're going to have these that are going to be recorded and put onto YouTube and also onto our website. I'll post a link later on through so far as our website for the rest of the events. It's going to be from here. You'll see at the bottom that you've got at the bottom of the window, you'll see a little sort of speech bubble. We're going to take questions at the end just so we can keep the flow going through it. But if you've got any questions or if you have any problems with volume or anything like that at all, please by all means tick that little button and send through your request, and I'll be on here whilst Vishal's going through from here. Next week's session is going to be based on service management, starters, movers, and leavers requests. So you may want to log on to that one. So they're going to be continuous moving on from here. So I think without further ado, I'm going to pass you over to Vishal, one of our main consultants here, to take you through this moving to Windows 10 piece.
Thanks, Matt. Good afternoon all and welcome. I'm Vishal Ladwa, end user computing consultant at Power on Platforms. I hope you can all hear me clearly. Thanks for taking the time out of your busy schedules. Today I'm going to be talking about moving to Windows 10. So let's have a quick look at the high-level agenda. Okay, so justifying Windows 10 upgrade. To start off with, we will look at the approach to traditional Windows operating system deployment projects of the past and the challenges and the digital disruption these projects introduced in the past. And we'll discuss the business justification and compelling arguments to move into Windows 10. Not only from a operational and financial perspective, but working out what's the cost benefit of taking on another operating system deployment project, having already completed maybe a migration project a couple of years ago, perhaps. Then we'll move into why move to Windows 10. Next, we'll explore the compelling reasons today why businesses are embracing Windows 10 and why you need to be on Windows 10 sooner rather than later. Next, we'll move into looking at the best options and practices and things you need to consider and be aware of for moving to Windows 10, and tools, namely SCCM, that can be leveraged to guide you through with not only deploying but also maintaining Windows 10 going forward. Finally, we'll explore a couple of options and tools that we can leverage to get you started with planning, like readiness assessment and evaluating your existing environment in preparation for Windows 10. Okay, so with that, let's get into it. Now let's look at traditional operating system deployment projects. In the past, almost all organizations went through an OS deployment project, usually every 3 to 5 years, to move to the latest version of Windows operating system, be it Windows 10, Windows 7 or Windows 8. And these would be typically big projects, lots of staff to support the upgrade, from planning, deploying to post-upgrade support. Lots of people and resources pulled away from their day-to-day jobs inside of IT and really pulled out to focus on 4 basic components all these deployment projects introduce. So a major one was validating the applications in terms of compatibility with the new Windows operating system. This piece alone could take months because you need to evaluate and determine what applications you actually have. This is where shadow IT installations can surface that maybe you weren't aware of previously. Secondly, updating the infrastructure to support the new Windows operating system, building a deployment process and building all the new images and content to support that build. So that can take quite a large effort. So basically a lot of work every 3 to 5 years. And this introduces naturally a lot of digital disruption to users and the business as a whole, which in turn impacts productivity. And in terms of the delivery time frame, quite often these projects, certainly a lot of the ones I was involved with, could prolong over many months, even years in some cases, over the expected delivery time frame, causing further disruption. Justifying an operating system upgrade is a hot topic, again, as a lot of companies are in the process of making the move to Windows 10 and trying to work out the cost benefit of the change and how it should happen. It can be a challenge to put numbers on the benefits to help make decisions on go, no go for Windows 10. So in June 2016, last year, Microsoft commissioned a report, Forrester Total Economic Impact Report, by industry analyst Forrester. So you can type that into Google and you'll find it. It basically provides analysis of real-world migrations to Windows 10 and breaks down the simple cost savings and productivity improvements from embracing Windows 10, and particularly security features, as well as highlighting improvements in deployment, ongoing management and maintenance, in particular with SCCM and the Windows 10 servicing model. Ultimately, it highlights, in a nutshell, that overall moving to Windows 10 was quicker and easier by as much as 50% compared to previous operating system upgrades. So this is on real-life migration data of early adopters, so quite high satisfaction rates compared to previous operating system deployments. For those of us looking for those type of answers, this is a massive help to understand the normal intangible benefits of moving to Windows 10, and again, that helps to make that decision. So take a look at that report if you haven't seen it already. So with Windows 10, Microsoft have put a lot of emphasis on security to make sure it's the most trusted platform, with features like Device Guard, Credential Guard, which we'll go into. Adding productivity, so there's faster boot times, convenient access to corporate applications and resources, better mobility tools, helping IT and users become more efficient and complete their work more quickly and effectively, especially mobilizing their workforce. With Windows 10 and SCCM, it empowers users with self-service tools. And all this kind of makes the Windows experience for end users more personal, and it makes them feel that they're in control, and that obviously adds to the satisfaction rate. Also, Windows 10 provides a lot of support for different types of versatile devices, so everything from phone devices to traditional desktops to the new Surface Hubs. So check those Surface Hubs out if you haven't already. In this age of modern workplace, work behaviors and patterns are changing, and users are demanding more freedom and mobility. However, this is a fine line, as we need to make sure corporate data is also secured at the same time. So let's take a look at what are the compelling reasons that companies are actually deciding to actually embark on the move to Windows 10. And these days, security breaches are frequently making headlines, which increases the financial risks due to the impact of lost productivity and the cost of the data breach. So the security features available in Windows 10 provide some of the biggest benefits, and is actually one of the most compelling reasons that organizations are actually adopting Windows 10 and looking at this sooner rather than later. So Windows 10 is the most secure Windows operating system ever. So what are some of the main security benefits that you could start leveraging by moving to Windows 10, and what are the threats that it actually safeguards against in the modern world? Well, to start with, Windows Hello. So to mitigate credential thefts, Windows Hello allows employees to authenticate using biometrics in the form of fingerprints or facial recognitions. So no password, no Kerberos hash tickets that could be compromised. and the biometric authentication data is only stored locally on the device, so it's never shared to external devices or servers. So that reduces the attack surface, and even if an attacker was able to get hold of the biometric data, it can't easily be manipulated to a form that could be used to get an unauthorized access. So that's a very useful feature. There's Smart Screen. So the web browser is one of the first entry points into your systems. So it continues to be a favorite target for attackers, which is why it needs protecting. When you connect to the internet using Microsoft Edge browser, part of Windows 10, it prevents you from going to well-known malicious websites that fool unsuspecting users into phishing attacks. So this blocks around 97% of the threats out of the box that are out there in the wild, which is great because there's still going to be vulnerabilities and exploits that can be bypassed, but at least 97% of the main threats are actually blocked by default there. Going into the kind of the main security features, so the secure boot, which is actually a Windows 8 feature, but more prevalent in Windows 10. So this prevents malware known as bootkits or rootkits from loading during the boot loading process, which is particularly tricky to detect actually, because it modifies the behavior to obscure itself when Windows does actually start up. Switching to UEFI mode goes some way to prevent this, but malware is always developing, right, to compromise the UEFI loaders. Secure boot, which is enabled in the UEFI firmware, will only load boot files from a trusted source, which is hard-coded in the UEFI firmware and can only be modified by the hardware manufacturer. So ultimately, any compromised or unauthorized boot files will not be loaded, and therefore the OS will be blocked from loading, preventing a wider breach there. So a very important feature. And then we move on to device guard. So this hardens the system against malware and zero-day exploits by blocking anything other than trusted applications in the full OS. So 0 day, meaning the hacker has exposed a new vulnerability in the code, which we're not aware of. So there's no fix or patch for that yet, right? Device guard blocks non-trusted applications by using hardware and virtualization-based security to only allow trusted code to execute as part of the operating system kernel, device drivers, services, all the way through to finally user applications that are loaded. The traditional approach with combating this is with antivirus software. So basically the rule is to trust anything unless it is known to be malicious. And then the virus definitions need to be updated and deployed frequently to protect against new threats like the 0 days exploits that do appear. In comparison, device guard starts with the trust nothing approach, preventing any code from executing unless it's been specifically whitelisted to be signed and trusted from the core kernel to the application layer. So to make sure only trusted code is actually executed, most enterprise application vendors sign their code, and you can deploy device guard policies typically managed via SCCM to define the signatures that are trusted in your environment. So using virtualization, device guard isolates the signatures from the operating system, preventing any malware or elevated users from tampering with that signature. And then there's credential guard. These days, malware is sophisticated and designed to be installed silently and undetected to the user who's been tricked into clicking a link or email attachment, which appears to be legit. So this is known as phishing. The attacker can then use a technique known as pass the hash, which is actually quite easy to do, to steal the credentials to spread malware to other systems. Ultimately, the hacker is looking for elevated domain credentials. And this way they can get access to elevated privileges, which gives them the access to the VIP resources that they're looking for, so they can exfiltrate it out, which is clearly their main mission. So once they're done with that, then that's mission accomplished. So to mitigate this threat, Credential Guard uses virtualization-based security to isolate and protect the hash credentials, to protect it against hacking or stealing from an attacker that's got hold of domain credentials. So by the way, hash credentials were previously stored and exposed in memory in earlier versions of Windows, like Windows 7, Windows 8. So a big vulnerability there. Now, app compatibility was a big deal in operating system upgrade projects for Windows 7 and 8. This was a major reason why projects would get delayed, and there was a lot of pre-planning involved. App compatibility is actually a much better experience out of the box with Windows 10. In fact, outstanding app compatibility, which means usually there's a smooth migration from Windows 7 or Windows 8 compared to previous projects. As highlighted in the Forrester report in the earlier slide, early adopters have gone through the compatibility tests, and the results are that typically there's a 99% success rate. Majority of applications will just work, and this is because in Windows 10 there are minimal changes to the Win32 APIs compared to Windows 7 and Windows 8, and feedback from the insider previews. So these are like advanced preview versions of Windows 10, which can be used for testing, which Microsoft release ahead of the full release to current branch. So this has actually resulted in a lot of issues with applications actually being fixed before release of the full operating system version for current branch. So yes, there are issues here and there. It's not totally seamless. These are the kind of typical things you would expect. Applications that are, for example, applications that are kind of hooked into low-level operating system components, like antivirus software tends to be the biggest violator to that, to the standard developer coding rules. So using undocumented APIs that hook into the operating system in non-natural ways can cause issues. But that's more like a few of applications that maybe will not work. Again, Windows 10, there's minimal changes in the Win32 APIs, so you'll find the majority of applications are compatible. So looking at the website compatibility, so there's two browsers included in Windows 10. There's the Edge browser and the good old Internet Explorer. So we use Edge for the modern HTML5 based websites. For the older stuff, there's still Internet Explorer and also in enterprise mode. So all your web applications that work fine with Windows 7 and Internet Explorer work the same with Windows 10 and in Internet Explorer. There is this enterprise mode capability. So with enterprise mode, you can configure it to work with both of those browsers together. So via group policy, you can configure the machine so that when the user launches Edge and types in a URL, for example, that isn't compatible, so Edge doesn't support ActiveX controls and VBScript and other legacy technologies. So if that URL isn't compatible for one of those reasons, it will redirect to Internet Explorer. And then they can work with that web page in Internet Explorer. Similarly, if in Internet Explorer 11 the user types in a website and doesn't actually require Internet Explorer, there's now a group policy in Windows 10 1607 which says redirect that back to Edge. So we can automatically use the best web browser for the particular website that's actually being accessed. So for most of the new stuff, that should be Edge. For these older applications that needs compatibility, that's Internet Explorer with enterprise mode. In terms of hardware compatibility, on that side is quite strong as well. So Windows 10 should run on any hardware capable of running Windows 7. Pretty much the same minimum hardware requirements and driver models, so most models should work. There may be a need for some driver updates, but most of that can be handled through the in-place upgrade process if that qualifies in your environment, and any incompatible driver can be dropped and updated with built-in drivers or additional drivers that are available in Windows Update. Okay, so let's look at SCCM and what that brings to the table. In my opinion, SCCM is objectively the best product on the market for deploying and administering Windows in the enterprise, especially in terms of Windows 10. So SCCM provides the greatest control over building, deploying, and servicing Windows, and provides the most scalable solution. So let's briefly look at what the current line of SCCM brings in terms of improved capabilities. So to begin with, the SCCM build. So first off, when you start working with SCCM current branch model, we're working with something called the baseline build. So the very first release of SCCM was a baseline build, which means that you can log into your Microsoft licensing site and you can download that specific version. Right now, if you want to install SCCM today, you want to get to 16.10, which is the latest version, but there's no baseline build of 16.10, so you have to download version 16.06, which is the latest baseline build, and then you can use the in-console updates in the updates and servicing node to take you to the next build, which would be 16.10. So in the past, those days of long, cumbersome upgrades from version to version are over now. It can actually handle that within the console. Microsoft supports each version for a year. Incidentally, if you're still on SCCM 2012 R2, mainstream support ended in July 2016, and it only supports deploying the first two releases of Windows 10, and one of those versions, 15.07, is no longer supported after March 2017. So if you want to deploy Windows 10 16.07, you need to be on SCCM 16.06 as a minimum to be fully supported and fully benefit from the changes the Windows 10 product group are making. So having said that, if you want to go fast with Windows 10, you have to go fast with SCCM. Technical previews, SCCM is stronger than before. So we see a massive investment from the product team. Ever since the first technical preview, we're seeing new technical previews every month. So I would encourage you to install these in a lab environment because some of the features in the technical preview will make it into the full product. So that gives you 3 or 4 months to play around with the features. There is a time bomb in the technical preview, so it will expire, but if you keep on upgrading, that time bomb will be reset. So 12 releases in the last 12 months is very impressive compared to if you're familiar with SCCM 2012 and the previous versions. So some of the new kind of features, in-place upgrade for the operating system. So previously, if you wanted to upgrade the operating system of the actual site server that SCCM is running on, you would have to make a backup of SCCM and restore it on a server after the new operating system was installed. Starting from 16.02, you can upgrade SCCM to the 16.02 or later release, and then upgrade the operating system in place. And this includes the scenario if SQL is actually running on the same box as well. So recently we've done this for quite a few of our customers as part of the Power On SCCM Fast Track offering, where they were running server 2008 R2, and then we uplifted that to server 2012 or 2016, and it actually works flawlessly. There's also the cloud management gateway. So internet-based clients are becoming more and more commonplace as the workforce is actually becoming more mobile. So how can we manage those? Well, today you can do internet-based client management in SCCM. That requires a lot of groundwork to set up client-facing servers in your DMZ network and your perimeter networks, and it requires a PKI infrastructure for secure authentication between the internet clients to those servers to access, your internal content, which can be tricky to set up and manage. So what we do have now is setting up a cloud management gateway, which is actually Azure service. So your clients on the internet can go to the cloud management gateway, which in turn can connect to the internal resources to get policies. If you need to download any software updates, you get instructed to go to Microsoft Updates to download them from there. To get any internal content, the clients can get that from the actual cloud distribution point, which is also an Azure service. So in this way, we can fully manage our clients on the internet without having to do any complicated setup. One of the hot topics around OSD deployments to Windows 10 is actually the BIOS to UEFI conversion. So a lot of the security features in Windows 10, like I mentioned, device guard, rely on UEFI. So it's important we're able to actually switch from legacy BIOS to UEFI in the Windows 10 build. Previously, SCCM didn't have the ability to gracefully make this switch from legacy BIOS to UEFI in a single task sequence, which makes things more complicated. So there were a few third-party solutions which work around this to get around this to get it to work seamlessly in a single task sequence via SCCM. SCCM now has that capability in 16.10 to actually do this natively using a built-in task sequence variable. So that's very important because you can now take advantage of the security features in Windows 10 a lot easier. And we'll talk about that in a little bit more depth a little bit later on in one of the later slides. Managing duplicate hardware identifiers. So we've come across this issue recently from a number of our customers. Personally, from previous customers in a different role, I came across this also. The reason is as modern devices become slimmer and more compact, and maybe we don't have physical keyboards, it's becoming commonplace that certain devices don't actually have inbuilt Ethernet NIC cards. So rather than having Ethernet adapter, they would have a USB adapter plugged into the machine to PXE boot the device in order to install the image. So the build process would be something like you take the machine out of the box, you plug in the USB adapter, PXE boot the device and image it. You're done, and you hand it over to the user. You now move on to the next device and plug the same USB adapter in, and PXE says no advertisement found. So the reason for that is these machines are out of the box and unknown to SCCM, so we're using unknown computer support in SCCM, but that MAC address for the USB device is not unknown because we've already used it to PXE boot the previous device. So SCCM remembers the MAC address to ensure that a machine doesn't end up in a loop, so continuously restarting and rebuilding. So it does that by design. Now in SCCM, actually in the console, there's the ability to specify non-duplicate MAC addresses. So you can specify all those adapters in the SCCM console. So when you reuse that adapter, SCCM will ignore that MAC address and it will go ahead and bring down the deployment. So next time you build multiple machines with that same USB adapter, they will work every single time. So I found that to be a very useful addition. Windows 10 edition upgrades. So this basically allows you to uplift machines from one edition of Windows 10 to another within SCCM. Within Windows, you could achieve this using a script or creating provisioning packages, which we'll explain in detail a little later. You can purchase an edition upgrade from the Windows Store. So now you can actually do this within SCCM. So you just specify the product key or the license file that you want to upgrade to, and deploy that to a collection of machines. The great thing is that there's no actual payload, so there's no large package of Windows 10 that needs to be downloaded and applied, no image. All we're doing is uplifting the product key. Windows 10 is already on the machine, so we have additional features there for example, if you need to go from Windows 10 Professional to Enterprise, for example. And then there's the WinPE peer caching, similar to branch cache in previous versions, but for clients in WinPE mode, so during the build, they can actually get content from another client that previously downloaded the content. This saves having to download from a DP over a slow WAN link, and it can actually be enabled through the client settings, and there's a bit of configuration to do on the task sequence to persist the client cache. So once it's completed, all that content is retained in the cache. So this feature can certainly improve build times, as the bulk of the OSD content is downloaded from adjacent client on the local area network. And then there's some general OSD improvements as well, which I won't actually go into too much detail. So let's move on. Okay, so Windows 10 deployment scenarios. So always in SCCM, there's a number of different deployment scenarios for deploying different Windows, and that's no different within Windows 10. Actually, the options are actually increased. So we still have the bog standard imaging, the standard WIM-based deployments, so wipe and load, or bare metal. Major system changes with hardware refresh and replace, they still exist. So a device might have come out of the box and it's got a new hard drive. So if there's no existing operating system on that device, we're actually going to have to image it, so we can add new stuff to it later on or down the line. You may have a refresh scenario where you need to preserve the existing user data and settings, and then apply that once you've done the wipe and load, and then you've installed the operating system. So you've installed Windows 10, and to do that, we can leverage the user state migration tool to actually preserve that user data and settings, and then reapply it once Windows 10 has been applied. There are some more complex scenarios where imaging is actually a must. So maybe an architectural change. You have 32-bit systems and you're moving to 64-bit systems. We talked a little bit about BIOS to UEFI conversion, and we'll talk a little bit more of that in the next slide. Or if you need to change your disk encryption provider, so you need to move from a third party to BitLocker, you're going to need a task sequence to do the heavy lifting, and then decrypt and then re-encrypt the disk. Some organizations, they actually take this opportunity, if you're doing a major operating system rollout, as a chance to start from scratch to make sure that the devices that they're deploying to the users are clean and best fit for the current working environment, not like 5 years ago. So wipe and reload is kind of the way to go in that scenario. So typically you'd still use SCCM or MDT to actually create that build and capture the actual golden image for Windows 10. It's not really changed there. Usually, as part of that golden image creation, you'd actually bake into that image only the C++ runtimes and all of the latest software updates, and perhaps even core applications, but that's actually it, nothing more. So very light image is the best practice. There is the offline servicing feature in SCCM, which is the process of actually injecting the software updates into the operating system image, the WIM file. So this is very useful. It can help simplify the build and capture, because what you'll be doing is on a yearly or bi-yearly basis, you might be updating that WIM image to shorten to make sure that the most up-to-date software updates are actually baked into that operating system. So when that's installed, you have the most up-to-date software updates from the get-go. So that offline servicing can help actually simplify that process. Then typically you'd leverage the task sequence to add logic to enable the machine to pixie boot or restart into WinPE, where it can actually run the task sequence engine, format the partition and the drive, install the operating system, install relevant model drivers, and configure the Windows settings like name the machine, configure the language locale, add the machine to the domain, move it to the relevant collection so that when the build is complete, it will start up in the full operating system, and when the user logs in, it will get all the relevant GPOs applied. And then after that, install the applications, apply any additional software updates that are not actually within that operating system image, your golden image, and then potentially add encryption, and so on and so forth. So everything that's required to complete a full Windows 10 build would be added into that task sequence, the deployment task sequence, to actually automate all those tasks. So from the beginning to the end, once you take that machine out of the box and you start the build, once it's completed, it's ready and provisioned. So that's imaging. And with Windows 10, we have the ability to do an in-place upgrade. So this is a new feature with Windows 10. So the upgrade is a great, quick and clean way to uplift the user from Windows 7 or Windows 8, and also, of course, with Windows 10 builds, of course, as well. The great thing about upgrading is that it preserves the user data and the applications and the settings. The in-place upgrade actually just swaps out the operating system from underneath that. So that's very useful. We also have provisioning as well. This is where the scenario where the user gets a device out of the box and it's already imaged with Windows 10. Then you can put a provisioning package down on that machine in order to lay down some control and configuration to that. So in the modern workplace, that's a very useful proposition. And then we have Windows as a service, so that provides that Windows 10 build-to-build upgrades, being able to go from Windows 10 15.11 to Windows 10 16.07 natively within SCCM without having to do a wipe and load. So we'll discuss that in more detail going forward also. Now, the strategy that you'll choose in terms of migrating or upgrading to Windows 10 really is specific to your environment and the desire to leverage the security capabilities in Windows 10. Chances are you'll probably use a mixture of those deployment methods that I explained in the previous slide. However, you probably will want to take advantage of the new Windows 10 security features, which require UEFI enabled devices. So this is one of the biggest complex scenarios that organizations are facing today and have experienced in the last the last year, certainly, the BIOS to UEFI migration. Now, the problem is if you've been deploying Windows 7 or 8 on newer hardware, but in order to get app compatibility and consistency across your estate, you've been putting those machines in BIOS legacy mode, we can't then uplift that to Windows 10 and benefit from UEFI. We can uplift it to Windows 10, but it will continue to run in that BIOS legacy mode. The only way to convert a BIOS legacy system to UEFI today and be supported by Microsoft, ultimately this requires wipe and load. So you wipe the box and reinstall Windows and build it up with the UEFI partition. So having said that, you have 2 or 3 options really. Do the in-place upgrade now and continue to use BIOS, and then wait for a hardware refresh later. As you start getting new machines, then you'll start making the switch to UEFI. Obviously, there are a lot of immediate benefits from moving to UEFI. You get the security features, you get the secure boot functionality, passport for work, Windows Hello. device guard, and all the trusted installer benefits that you get with that. Other than that, there are a few third-party solutions that work around to get around this to work seamlessly in a single task sequence, and they do all work. There's also a workaround that ultimately requires two task sequences within SCCM, one to do the reformat and then one to do the rebuild of the new Windows 10. So SCCM now has that capability in the latest version, 16.10, to do this natively in a single task sequence approach, using a built-in task sequence variable and leveraging the OEM conversion tools that Dell, HP, and Lenovo provide for that conversion and run that natively in the task sequence. Ultimately, it still requires a format of the machine. So if you need to preserve user data and settings, you're going to have to go down the user state migration tool route, so the refresh scenario. But it will certainly provide a significant effort reduction because you now have that one task sequence to achieve the BIOS to UEFI conversion. Although one thing is it's not supported for in-place upgrade. So that's very important because it's a very useful feature because now you can actually take advantage of the security features in Windows 10 and simplify that deployment process and being able to do that natively within SCCM in the latest version. Another option is, although if you already have devices configured for UEFI, then you can use the in-place upgrade deployment method, and it will retain the UEFI partition there. Going forward, Microsoft is going to simplify this process with the next release of Windows 10 called Windows 10 Creators Update. If you already have provisioned modern Windows machines that support UEFI but have Windows 7 installed using legacy BIOS, converting a device to UEFI mode would require repartitioning the disk, change it from MBR to GPT and reconfiguring the firmware. The Windows 10 Creators Update will introduce a simple conversion tool that automates this previously manual work, and it can be integrated with SCCM as part of the Windows 7 or Windows 8 to Windows 10 in-place upgrade process. So there is a blog post describing it. In the Microsoft blog post, they only mention a simple conversion tool. There's not that much of a detail behind it, like when to expect it, how to use it, etc. So it's included in the latest Windows 10 Enterprise Insider Preview, so you can actually check it out there if you need to grab a copy of that and spin it up in your lab. Okay, so why would you use wipe and load or imaging as opposed to in-place upgrade? So if you want to do a major configuration change, like change domain membership, or if you want to do major application changes, then task sequence with wipe and load are probably the best option. We talked about the fundamental changes you might need to go through as part of your Windows 10 migration. So change disk partitioning, that BIOS to UEFI migration, moving from 32-bit to 64-bit. So you can't upgrade a 32-bit operating system to a 64-bit operating system. These are the types of scenarios that you would actually require a wipe and load method, so imaging. And then any custom requirements, such as you want to customize the WinPE boot image or customize the base Windows 10 image. Upgrade doesn't actually support a custom image, only the default image that ships with Windows 10. Or there's a requirement for a third-party disk encryption. Then again, as we discussed, wipe and load is the best option there. So why would you use in-place upgrade as opposed to imaging? The great thing about upgrading is that it does preserve that user data and the applications and the settings. The in-place upgrade actually just swaps out the OS from underneath that, right? So the administrative overhead is of going from one build of Windows 7 or 8 or even 10 should be reduced significantly through upgrading. because you don't need to make sure all the drivers, all the applications, etc., all that content that's required for the operating system deployment, whether they're in the image or as part of the task sequence, you don't have to worry about that. That's all taken care of as part of the upgrade process. So all that is preserved as part of the upgrade. If that's not a compelling enough reason compared to imaging or refresh, upgrading is actually faster. Taking on average approximately 30 to 60 minutes compared to a common issue in previous operating system migrations is the build time. And I've experienced build times taking 2, 3, 4 hours, and that's because they've got so many drivers, applications, so much OSD content that actually needs to be downloaded and installed as part of that task sequence deployment. So obviously that's a lot of heavy lifting, and that takes time to adds time to the significant time to the actual deployment. The other compelling reason is it's more robust, because if there's a failure, Windows will take you back to the known good deployment of Windows. So if you go from Windows 7 to Windows 10 and it fails halfway through, the upgrade process will actually roll you back to a working configuration rather than just leave a random error message to troubleshoot, and obviously you've got a user that is not able to use a machine and go on with their business. The other way of deploying Windows 10 that we touched upon is provisioning Windows 10. So this is a great solution for your kind of bring your own device scenario or choose your own device scenario. So rather than get a device provided from the IT department, the user is actually purchasing the device themselves from PC World or Amazon, rather than imaging that machine using the corporate image that was created by the IT department. So for provisioning, we use the existing Windows 10 OEM build provided by the manufacturer that ships with the device. And then we apply some provisioning steps to lay down just the configuration side. So you would plan and determine what you need to configure on those machines based on that scenario. Create the provisioning package which defines the settings that are required, and then you have a process where the user boots into the device, enrolls the device, and then the provisioning package is applied. And the configuration is as part of that enrollment process, where they're actually joining that device to the corporate network. And then once that device is provisioned, it's got the configuration and lockdown that you need, and it becomes a normally managed device in your environment, either using the MDM Intune hybrid solution with SCCM or directly with SCCM using the SCCM client, how you would manage traditional clients using SCCM. So how do we create a provisioning package? This contains the settings and the configuration that we want to apply. So the provisioning package would actually contain that, and we can apply this at various stages of the life cycle of the provisioning of that machine. So the provisioning package is created using the Windows Imaging and Configuration Designer, or WICID, which is a feature of Windows ADK. Once this provisioning package is created, it can be deployed using Intune or SCCM. So, Intune standalone, hybrid, or SCCM standalone. It doesn't matter. You can actually deploy in any of those scenarios. So it allows you to configure without imaging that machine. There's a vast amount of settings that you can actually leverage as part of that provisioning package, from start menu customizations to edition upgrades, to the configuration of applications, be it modern style applications or traditional Win32 applications, and then you can also manage the security policies as well. So how can you, outside of SCCM and Intune, how can you apply these provisioning packages to these bring your own device style devices? So usually the organization would have some kind of defined provisioning procedure where the user gets the go ahead to buy the device from Amazon or PC World. So we can get the user to apply the provisioning package through the out of box experience. So they can press the start button 5 times and it will give them the option to apply the provisioning package that the IT department has actually provided for them, be it via a USB dongle or an SD card, or it can also be done through an NFC transfer as well. Or they can apply at runtime, so provide them with the actual PPKG file, which is the provisioning package file, and then they can actually apply that, again using the USB dongle. It can actually be sent by email as well, or if the IT department actually gets the device before the user, then they can actually get it transferred like that, or they can actually send a link to download it from a location, from a secured location. There is also the option to embed that into the image if you have an agreement with the hardware manufacturer. So, for example, with Dell, you can pay them to include that in the image before the device is actually shipped out to the user. So it's actually automatically provisioned as soon as the user gets it out the box. The machine is ready. So yeah, so it's a very powerful tool, especially given the current trends we're seeing in the landscape today for modern desktop management and the user demand for enterprise mobility. This is the trend that we're seeing today. So Windows as a service, Microsoft have changed everything about the way we actually build and deploy and service Windows. From a building perspective. Windows as a service changes the way Windows is released, the way Windows is previewed, the way you can see what's coming. So there's the insider preview program. This shows you the builds of programs as Microsoft are actually writing the code. You see almost weekly the progress that's being made, and you can try it out and provide feedback. So those issues can be fixed in advance. So I mentioned earlier regarding the app compatibility and how that's really improved, and the insider preview program is an actual driver of that. So you can actually use those insider preview builds to validate in your own infrastructure and your own applications to make sure that it's not breaking anything. Whereas in the past, the process would be, let's develop the next Windows for the next 2 or 3 years, which is a static process by comparison. This is much more agile, and this is really come about from a demand from users needing more mobility, needing constant updates. In this day and age, we're faced with security threats, and all these things come into play for this kind of Windows as a service model. From a deployment perspective, it changes the way the Windows is installed as well. So there's always going to be scenarios when you need to do the traditional wipe and load deployment, but you can simplify this by using in-place upgrade processes to service existing Windows installations, as mentioned, and making it as easy as possible to keep up to date with deploying feature updates to your existing devices. From an overall servicing perspective, the patching process is greatly simplified from what we experienced in the past. We don't want to deal with dozens of patches and all of these complexities. It just simplifies it down to a single cumulative update that you can just apply to your Windows 10 device and bring it up to the current point. Regardless of whether it's been updated last week or if it's been disconnected, or It has different patches compared to it has a different patch trend and drift compared to other machines. So the idea is basically you patch it with the latest cumulative update, and that's it. That's all you have to do. So different stages of the build are actually made available. So if you want to see what features are coming, obviously there's the insider preview builds. So yeah, that gives you the opportunity to provide feedback so they get fixed and addressed. Once the current branch version is released, you can use this version to begin doing the pilot deployments to a subset of machines to try out new features and validate against your applications and infrastructure and provide any feedback. Next, after 4 months, a proper release actually comes out and is considered as current branch for business, which is considered good for broad deployment. So it should be deployed to 80 to 90% of the devices. And then there's also this long-term servicing branch build, which is really for kind of specialized systems, like, for example, like ATM machines, like factory devices controlling machinery, for example, or machines controlling high-end medical equipment, like say a heart monitor or important life-saving equipment that's being managed by that Windows device, where you can't be pushing out a new build of Windows 10 every 6 months. You need to have that locked down. So basically, if it's got Office installed on it, then it's more of an information worker device, so probably not a specialized system. And really, the intention would be that would kind of go under the current branch for business build. So if you got specialized systems where you don't want any change to happen to them over a long period of time, in terms of feature updates or security updates, it would be the long-term servicing branch. So this would really be a small subset of machines in the organization. So when we're talking about patching with Windows 7 and Windows 8, the traditional approach is to selectively patch your machine. So we tend to deploy all the security patches that are released, but not all of the non-security updates. So it's kind of leaves us in a situation where we've got all these machines that have different collections of patches, like a lot of drift between them. With Windows 10, it's moved away from that, and from that pick a different patch for that category model approach, to using that single cumulative update. So each new one is released, supersedes the last one. And that's all you need to basically make sure that it's fully patched. There's two types of updates: quality updates. So a single cumulative update each month on Patch Tuesday, containing the security fixes, reliability fixes, any bug fixes, all rolled in together into one cumulative update. So it always supersedes the previous one. So part of that, there are no features that are added. And then we have the feature updates. So 2 to 3 times per year, these are released. Yeah, so in terms of the patching, this can all be deployed using different methods. So SCCM can be used to deploy the patches, MDT, WSUS, and even Windows Update for Business as well. Okay, so let's look at how to get started with planning, like readiness assessment. One great feature of the upgrade, in-place upgrade, is that we can actually assess the readiness of the machine using a task sequence and using a servicing step within that task sequence, and deploy that out to your estate to get some information back on the suitability of the current estate in terms of moving to Windows 10. This is done by leveraging the Windows Setup Compatibility scan on the upgrade operating system step in the task sequence. You basically select an option called Perform Windows Setup Compatibility Scan without starting the upgrade. This will report to the machines that you've deployed to, whether or not they're ready for running Windows 10. So it does require the entire operating system package to be part of that content and downloaded by the client in order to run that compatibility scan. And then it returns whether or not we are going to be good to go for that particular device for moving to Windows 10. So there's two types of scenarios. You could use this as a fact-finding mission by deploying it to the full estate or a subset of your estate. Or you could use it as a kind of a nice check method in your actual proper OSD task sequence to upgrade the machine. So you can provide it logic to determine whether to go on and perform the upgrade or to back out if it doesn't meet the requirements. So that at least it will leave the user with a working device without having to upgrade and then roll back. So the kind of information that we get back is we might get application compatibility errors or issues, so it'll flag that up. It might be that the machine isn't actually eligible for Windows 10, so in terms of hardware requirements it might not have the right chipset or processor or enough RAM, so it doesn't basically meet the minimum specs and requirements. Or it could be something like it doesn't have enough disk space to perform the actual upgrade. So using this data allows you to intelligently determine whether or not to attempt an upgrade rather than finding out further down the line, it fails and then it rolls back. So very useful information. And finally, this is actually a very powerful free service that will help you with the app compatibility side of things as well. So the Windows Upgrade Analytics service. So if you are planning a Windows 10 upgrade, this is a free cloud-based solution by Microsoft, which is actually part of the OMS suite, the Operations Manager suite, and that provides client telemetry to discover and evaluate applications and drivers in the current environment. Then it actually presents this back in the form of reports to enable you to gain key insights into accelerating your Windows 10 upgrade and planning that out. To sign up for it, you go to the OMS homepage and create a subscription and add upgrade analytics solution to that. You don't need to deploy a agent to the client as such. There's no OMS agent that goes out. It just uses agents found in Windows Update. So you just have to check that the specific KB numbers and make sure that they're installed on the client. Once these are installed, it takes approximately 48 hours to show up in the actual upgrade analytics portal. If there are any known app compatibility issues, they'll be flagged. So you get lots of useful information to help you plan your move to Windows 10. So yeah, using this data is going to help you plan that out. So I urge you to have a look at that if you're planning Windows 10. So that's actually the end of the presentation. We can open up for any questions. Over to you, Matt.
Great. Hi, everyone. So hopefully that was of use for you. Got a few questions, and also I'll just run through what the next events we've got coming up, both as the next webcast sessions and also in-person events as well. So I suppose anyone got any questions at this stage? The typing box. There we go. We've got one coming in from Tim. Do you need OMS to use the upgrade analytics service?
No, you can sign up. It's a free service, so you don't actually need to purchase anything there. You don't need a credit card. You don't need to enter a credit card details or anything. So you can just sign up for that. It's free. It's obviously a cloud solution. So
great.
Hope that answers your question.
Yeah, maybe not so many questions there, which is fine. Let me just put through what the next events are. So I'll just take over the screen from there. Here we go. So we've got a few I've got a few events coming up. All these are free of charge completely. So the next ones we've got coming up are next week's webinar is building a starters, movers, levers process. I think that's with Damien. That's going to be doing that one next week. And then we've got some live events coming up. So we've got the Azure migration path. That's the steps and processes needed to get to Azure. From all these strategies, doing those first steps, even setting those foundations, and then how to actually do the migration and automate those processes afterwards. They're either in person on the 7th and 8th of March at Paddington and Manchester, or we've got those as a webcast as well. I think we are potentially sold out on the Paddington one. I think we've got more than we potentially need, but you can more than welcome to pop your name on there just in case we have any cancellations, which we may do. And then the next step from there are the ones that we're doing, which are quite intimate events, which the 28th, 29th and 30th of March in London, Manchester and Edinburgh, and that's protecting users' workspace. So it's a combination of a bit of a deep dive onto Windows 10 and some of the features from there, a continuation of some of those features that we covered today, and also then linking into the EMS suite and how the two sides fit together. So as ever, we have all our events coming up on our website, which is underneath from there, and I say they're all free. Great if you can pop some feedback through, and just let us know if you want to continue on subscribing to some of these podcasts. So far as anyone from PowerRun, thanks ever so much for joining us this afternoon, and we'll see you very soon.